Alright, in this video I have GPU-based occlusion culling, and I'll give a brief description. Anything that's in white is getting rendered, and anything that's red is occluded and then won't get rendered. And I'll do, for instance, this tower right here and this one will eventually occlude these rows of geometry, and then the boxes will turn red. So that when it's red, it means it's not being rendered. Here's another example. This is always occluded, so it's always red. And this will eventually turn white. Yeah, there you go, as the bounding box is visible and not occluded. So this is happening on the GPU, so if your phone supports GPU occlusion culling, it'll automatically work. I was also going to do CPU-based methods, but I fell behind, so I chopped it from the schedule. But this gives pretty good results. One thing that I discovered is for your occluder geometry, which are, the boxes that you see around here, many people will make a box for every one of these object types. So if you have, say, 30 different types of objects in the level, they'll make geometry for each one. So each one will have a different box. And one optimization you can do so that you only have one box regardless of how many different types of geometry there are is record the width, height, and depth of the box. Then all you do is you just create a scaling matrix and tack it onto the transformation matrix for the box you're going to render. And then you only just need a unit cube. And then the matrix takes care of scaling the cube to the dimensions of the geometry that you're going to do the occlusion test for. And you save all that memory and you only need a unit cube. That's what I'm doing for everything here. There's only one box being rendered, and it's the unit cube, and then the transformation matrix takes care of scaling it to the dimension of what you're testing for occlusion. So it works fairly well. It means that I don't render objects that are visible. Now with the iPhone, the advantage to doing this is not really in the pixel shaders, because the PowerVR chip has a perfect hidden surface removal. So for instance, this red box here, the pixel shaders will never be triggered to render this box, because the PowerVR chip can figure out that that object is hidden and shouldn't be rendered. So a pixel shader won't be triggered for that box. However, you're still going to incur vertex processing in the vertex shader, even though this object is occluded. So if this was a heavily tessellated object with a lot of vertices, there would be a significant gain in not rendering it, because the vertex shader wouldn't be called. And again, especially if the vertex shader is also fairly complex and you have a lot of vertices, that's a big win. In this test case that I'm running here, it's really not important that I have occlusion culling, but eventually when I have levels up and running, this will make a difference, and I can also reduce draw calls and processing, because that's one of the advantages of an efficient renderer. The way you get speedups is by not doing work. The less work you do, the quicker the renderer runs. So this is just another tool in the arsenal for optimization. And the artist can detect or determine what needs to use occlusion culling and what doesn't. So during export, they tag certain geometries as being candidates for occlusion culling, and I take care of the rest. And it also works with animated meshes. So for example, assume I have an animated object and it's hidden behind the wall. Well, the advantage is I save on the draw call and the vertex processing, and also on animation, because I don't have to animate the character, say, on the CPU if he's occluded. And again, I would use the animated bounding box with the optimization where I tack on a scaling matrix to the transformation matrix to do the occlusion test. So that's pretty much what I have for GPU occlusion testing. And in the next video, I'm probably going to do a character controller or some sort of collision detection, but I'm going to be doing some research first before I attempt it. So that's it for this video. Thanks, and bye.